Okay, well, I do hope that everybody had a good 3-day weekend. The quiz, remember what I was just talking about. Please make sure you have the homework done before you retake if you're wanting to. You'll have until next week. As soon as I go ahead and get the website created for next week, I'll go ahead and put down a definite deadline, but it's going to be by Wednesday or Monday or Tuesday of next week that you can go ahead and retake that. But we do have another inverse function quiz tomorrow, but it's a CFA. So this one should be pretty much guaranteed. It's just 3 questions. What are the domain and range for sine inverse, cosine inverse, and tangent inverse? It's multiple choice. You won't have your notes, so you do need to know those. Should take us all of like 1 or 2 minutes. Okay, there's no mathematics on that. All right, so that's coming up tomorrow. You walked in today, you got the assignment for our current lesson. It is due in 2 days on Wednesday. We should have the opportunity today to go ahead and start looking at questions off the homework. The big one, of course, in exactly 1 week, we have what I believe is going to be the final grade of the 6 weeks and the semester. It's the second exam. It's going to cover both lessons over inverse trig functions. So I'm glad at this point I did go ahead and move it to Monday the 16th because now you have a better idea of what that test is going to look like. It's going to look very similar to the test you just took. The only difference, it will contain cosecant inverse, secant inverse, cotangent inverse, and there are 2 questions on there where you're going to have to measure with a protractor and give me the angle measure that way. All right, so that's coming up on Monday in a week. The only other bit of information I need for this week, on Friday, I will be on campus, but I won't be in the classroom, so there will be a substitute here. That is the plan, knock on wood, as of right now. Anyway, I'm going to be taking the day to grade essays, so I am super looking forward to that. It's going to be an amazing day, but the substitute will have something for you to look at on Friday. Any questions about what's coming up? Because next Friday is it, the end of the semester, end of the 6 weeks, and we are on vacation again. Okay, anything. Now the quiz, I will get those graded and into, I keep wanting to say teams, but frontline before the end of 4th period, so they'll be in there pretty quick. Tomorrow I'm going to pass those back. First thing we'll do is talk about any questions you might have. Now, one of the things you picked up on the way in today were these trig identities. This is what we're starting tomorrow, and it's really important. We are not going to be able to finish this before Christmas break, so we're going to continue this after the break. But I wanted to go ahead and give this to you just in case you had a few moments. You can go ahead and start to look it over because these identities are going to be super important to you. Okay, well, let's go ahead and continue our lesson. I don't think we had a whole lot left. On Thursday, we started talking about the inverses of the other 3 trig functions, and we talked about how we're going to solve these using the reciprocal trig function and the reciprocal ratio. What does this word arc mean? Yeah, it's just another notation for inverse. Okay. For example, secant inverse is the same as arc secant. Now, the only trig inverse that you want to be careful of was cotangent inverse, and you wanted to pay particular attention to the sign of the ratio. If the sign is positive, tangent inverse of 1 over x. Oh, okay. If x was negative, less than 0, tangent inverse of 1 over x plus pi. If it was 0, then cotangent inverse of 0 is simply pi over 2. This is the new information that will be included on your test Monday. Okay, well then we went through, I believe we got through these 4 examples. Did we get either 3 and or 4 done? We did 3. Okay, so what I'm going to go ahead and do now, I'm going to go ahead and skip to numbers 5 and 6. Kind of look away very quickly. There we go. I got it erased. Let's go ahead and do 5 or 6 because I think they're going to be more important. If we want to go back and work number 4, we can absolutely do that. But I would go ahead and say after 5 and 6, maybe we could just put our attention on the assignment and start looking at those questions. But I'll let you guys decide what you'd like. Okay, so example 5. Find the exact value of cosecant of cotangent inverse of 1/2. Okay, so I have another composition. Okay, so what would I do? How do I start a problem like this? Okay, what's that, sir? So he says I need to find I know what you're looking for. It starts with R. The reciprocal. Okay, so I'm going to start with cotangent inverse of 1/2. Cotangent inverse of 1/2. Okay, well, what's the reciprocal of cotangent? Tangent. So I'm going to write this as tangent inverse of, and I want to take the reciprocal of the ratio as well. Now, I know it's 2. I'm going to go ahead and write it as 2 over 1 because we do need, the two sides to go ahead and diagram my triangle here. So tangent inverse of 2 over 1. Well, what quadrant would I now go to? Okay, 1. Now, tangent inverse is restricted to either 1 or 4. We're going to 1 because 2 over 1 is what? It is a positive fraction. Okay. So choose the quadrant based on sign. I'm going to draw my right triangle. Always connected to the x-axis. Now, tangent wants y over x, correct? Or y over r, I'm sorry. No, I was right the first time. That's a Monday. Y over x. So I have the opposite y is 2. The adjacent x is 1. There we go. So what would the radius be? Square root of 5. There we go. Would anybody like me to run through Pythagorean theorem? Okay. Is this a special right triangle? It is not. So go back to what we know about these functions. If you know these two details, an inverse trig function will always produce a what? Will always give you an angle measure. A regular trig function will always provide a ratio. So tangent inverse of 2 over 1, that's going to have to give me some angle measure. In the triangle that I drew, specifically, it's going to be this reference angle right there. Okay. Now, this is one of those problems. Is this a situation where I absolutely have to know what that theta is? No. Okay. Whether I do know that theta or not, what would I do with that angle measure now that I have it? I would just plug it into the next trig function. Remember, the output, the answer I get for the inside function becomes the input for the outside trig function. So I just want to go ahead and evaluate cosine of theta. Well, you remember cosecant wants r over y. So looking at this triangle, what is the radius over y? Square root of 5 over 2. There we go. Now, this wasn't a special right triangle. If I actually wanted to go ahead and find that measure and I wasn't going to use technology, well, what would I do? I'd have to, what have we been doing with the protractors? I would have to measure it myself. I would have to diagram and actually draw out these correct side lengths. Okay. All right, so let's try this next one. Find the exact value of secant of cosecant inverse of -2. Let's try this one on our own. Okay. Now, this one, like the previous, how do I know that my final answer has to be a ratio and not an angle measure? What about the composition tells me that? Yeah. The last thing you have to evaluate is secant. It's just a normal trig function. Remember, a normal trig function will always provide a ratio. Now, if it were, say, reversed, if it was cosecant inverse of secant of 2, and I don't even know if that would provide an answer, but if it did, the final answer here would be an angle measure because the outside trig function is an inverse this time. Okay. But this one's going to give you a ratio, just like number 5. Excuse me. So let me go ahead and catch up to you. You may or may not be done, and that's okay. By show of hands, who believes they have the final answer? Got a couple hands going up. Connor, what do you think?
Secant of negative square root of 3 over 2.
Square root of 3 over 2? It's not square root of 3 over 2. Sorry, sir. Anybody else? Okay, what do you think, Jordan?
Negative 1/2.
It's not negative 1/2. Sorry. Galen? 2 over the square root of 3. That is correct. Now here's the thing. 2 over the square root of 3, what would we want to do with that? We would want to rationalize. Okay, so 2 over the square root of 3 would give me 2 square root of 3 over 3. So that is the correct answer. We would just want to rationalize. How many people got that? Okay, good. That's actually several hands going up. Now let's talk about that. Walk me through this problem. What would I do first? Graph it. Okay, graph what? Okay, the reciprocal. So I'm always going to start with the inside function. So cosecant inverse of negative 2, what is the reciprocal? That would be sine inverse of what? Negative 1/2. Now, it looks to me like the grid provided is already really trying to tell you quadrant 4. Why would this one be telling you that? Because it's a negative ratio. Remember, sine inverse, just like tangent inverse, is restricted to either 1 or 4. So knowing that, I'm going to go ahead and draw a terminal side here. Always connect it to the x-axis. All right. Sine is y divided by r. So I know the opposite y would have to be in the negative 1. I know this would have to be the 2. Radius is always positive. What's the missing side? Square root of 3. And we can easily find that by using the Pythagorean theorem. What kind of triangle is created? It is a 30, 60, 90. What's the reference angle here? It would be 30 because it's directly opposite the shortest side. So this is 30. This one's 60. So sine inverse of a negative 1/2 would be negative 30 degrees. Why is it negative? It's in quadrant 4. Remember, sine inverse and tangent inverse, if you're in quadrant 4, the answer has to be negative because you always rotate from standard position to get into whatever quadrant you need. So this is just the inside. We solved cosecant inverse of negative 2, and we ultimately got negative 30, and that makes sense because an inverse trig function will always produce an angle. But what do I do now? That's not the final answer I'm looking for, though. What do I do with the negative 30? There you go. The answer I got for the inside trig function, I'm going to plug it directly into this next one. Okay. Now here's the thing. I can use the exact same triangle here because it wants me to rotate negative 30 degrees, right? Well, you'll notice this triangle is already rotated negative 30 degrees. You can either go ahead and create a new triangle, the one you're accustomed to using on the happy minutes, okay, the unit circle, or I can just use this one right here. What would you prefer? Just use this one? Okay. So I know I want secant of negative 30 degrees, so I'm going to use this triangle. Well, what does secant want? It always wants the radius over x. Well, the radius being 2 over the x square root of 3, and that's exactly what Galen gave me. So this is 2 square root of 3 over 3. Okay. Would anybody like me to go ahead and draw a new triangle based on the negative 30 degrees and show you that you're still going to get the same answer? Okay, you want me to go ahead and do that? Okay, so let's say we do. Now remember, I'm just evaluating secant, right? So forget about that other triangle that we have drawn. Let's say this is my negative 30 degrees, so this would still be 60. But if I'm just evaluating a trig function, it's on the unit circle, where my radius is always 1. What's across from 30? 1/2. What's across from 60? Square root of 3 over 2. And we're in the 4th quadrant, so y would have to be negative. So again, secant wants r over x. So r over x, the radius being 1, over x, square root of 3 over 2. Well, what do I do when I'm dividing by a fraction? You multiply by the reciprocal, but this gives me 2 over the square root of 3, which becomes the exact answer we already found. You would just have to rationalize it. Okay. Now, go ahead and compare numbers 5 and 6. Remember, we kind of had to take, I guess go ahead and call it a leap of faith. We didn't know what this angle was, but what did I still do with it? I still plugged it into the very next function. The only difference between numbers 5 and 6 is that on 6, we did happen to end up with a special right triangle so that I knew this angle. So whether I know that angle or not, see, I still just plugged it into the next function because it's the value of the composition I'm looking for. I don't necessarily need to know everything on the way there. Is that okay with everybody? Yes, ma'am. You talking about this one right here? Oh, yeah. We did not need this triangle here. If you realize that they're both going to be similar, in fact, if you take a look at it, compare the two sides. This triangle right here that we did use, what would happen if I just divided them all by 2? See, that gives me the other triangle because they're similar to each other. It's the similarity that allows us to do this between those triangles. If the similarity didn't exist, then all of what we did here would fall apart. Okay. How's that? How many people have gotten number 6 right? Okay, so that's not bad, not bad. Okay. Now, here's where you guys are going to make your decision. Would you like to go back and do number 4, or do you just want to go straight to the assignment? You do want to do number 4? Okay, let's do it. Okay, so let's see here. It says find the value of cotangent inverse of 1/2. All right, so let me go ahead and move this stuff here. In fact, does this one kind of look familiar? Wasn't it the inside function for number 5? Okay. So if we had done it, we could have just used that value and plugged it in. But see, even without it, we were able to get the answer. But let's go ahead and run through this. So for number 4, we are actually going to find out what that angle is. So let's see here. Cotangent inverse of 1/2. Well, we already said that is tangent inverse of 2 over 1. So let me diagram this triangle very quickly. It was in quadrant 1. Okay, we had 2, 1. We ended up with the square root of 5. So this is the triangle that I actually want to go ahead and diagram right here. I want to measure the sides to see that I get this same thing. Well, this one's actually pretty nice to me because there's no radical expressions. So I need a triangle whose base is 1 centimeter long. Okay, so I'm going to come on over here. All right, so let's say 1 centimeter is about right there. Okay, about where I made that mark. Okay, now right there, I'm going to go ahead and measure up 2 centimeters. So maybe about right there. So I'm going to make a mark right here. Let's see. Okay, so about right there. Would everybody agree? Okay. And for the test on Monday, I'm going to have the protractors available. I'm going to have the rulers available. Okay. The calculators will not be available, unfortunately. So now I've got a triangle that has 1 centimeter by 2 centimeters. And what's most important here is my hypotenuse. I'm going to make sure to draw that with a straight edge, but I'm going to draw it beyond the figure because I need to see where it hits on my protractor. So I'm going to go ahead and start at the origin, and I'm going to go ahead and put it right where that 2 centimeters stops. So hopefully, if I were to measure it, this right here should be the square root of 5 centimeters, or it should be really close. Remember, doing this by hand, is it ever going to be perfect? No. Okay, probably not. So let's see here. What I now need to figure out is how far from standard position did I rotate to get to that hypotenuse that I just drew. So let's see how close I got. So again, I'm going to take that crosshairs. For yours, if you're using mine, it's just going to have the open circle. I'm going to place that, right on the origin right there. So what would you say, based on what you see, you'd say about 62 degrees? Okay. Would you guys agree? All right. So let's say about 62 degrees. So let's see how close I got. If I come on over here, cotangent inverse, what was it, 0.5? 63.43. Okay. So how close did I get? Pretty close. Let's say if I were taking my own test, would I get credit for that?
Probably.
Yeah. Because remember what I'm going to do, I'm going to go ahead and use technology to get the exact answer, and then I'm going to go 3 above and 3 below. So I think that's a pretty good window, good interval right there. Hopefully should take care of any measuring mistakes you might have. All right. Noe, is that good? Okay. So now that we've got that done, let's turn our attention to the assignment. So we have, what, about 10 minutes? Well, we got plenty of time. 9 minutes maybe. Okay, let me get rid of this. Okay. Is there anything that you're already noticing on the assignment that's due when? Wednesday, so you still have 2 days that you would like to talk about together. 16? Okay, so let's see here. It says find the angle measure for each expression. Do not use a calculator. Okay, so arc cosecant of cotangent of pi. Okay, so let's go ahead and take a look at this one. Now, how would I work a problem like this? Where would I start? Okay, I'd start with the inside trig function, cotangent of pi. Now, this one is just like your happy minutes. I just want to evaluate a trig function at a location. So here's pi. So there's no triangle. That one's actually a what? Quadrantal. So what's the ordered pair at this location? It's -1, comma 0, right? Well, remember, what does cotangent want? Cotangent wants the x over the y, right? So according to this, what's going to happen? If this is the x, here's the y. So I would take -1 over 0. So what do I get? It would be undefined. I'm not going to get an answer out of that. Now, that doesn't necessarily mean that I'm going to end up having a problem here. Okay. Let's say I were to go ahead and plug that in here. Let's see if I can still take care of the composition. So arc cosecant, cosecant of undefined, well, that would be arc sine of undefined, right? Remember, that arc is just another way of writing the inverse notation. Now, see, here's the thing. Because I have an undefined ratio, what am I not going to be able to do? Okay. Well, let's say I did have a ratio. I did have a fraction. What would I do with it? What would I draw? I draw a triangle. So I don't have a ratio. So what can I not draw? Can't draw a triangle. Now, here's the thing. We've seen these before. If I'm not able to draw a triangle, where am I looking? It's got to be one of the axes. What do we call those? We just mentioned it. A quadrantal. Now remember, sine inverse is going to be between quadrants 1 and 4, right? Okay. So there's 3 possibilities. We have -pi/2, we have 0, and we have pi/2. So let's look at those locations. At -pi/2, we have 0, -1. At 0, we have 1, 0. And what do we have at pi/2? 0, 1. Okay. Now, I'm trying to solve for sine, right? Arc sine. So that means I want the y over the r. Okay. Y over r. Well, where am I going to get one where it is undefined? Oh, and actually on this one, we didn't even need to take the reciprocal, did we? Because think about it. Let's actually take a step back. What is cosecant's ratio? We didn't need to take sine inverse, the reciprocal. What's cosecant? It's r over y. Now remember, we have a 1, so which one's this going to apply to? This one's going to be better. Which one's going to be undefined? 0. So arc cosecant of cotangent of pi would just be 0. In fact, let's see if I actually did that one correct. Because I'm about 99% sure I did it right, but there's always that one nagging feeling. So cosecant inverse. Now mine's in degrees, so I'm going to say cosecant inverse of, what was it, cotangent? But I'm going to have to plug in 180 degrees because that's what my calculator is in. Okay, no, hold on, wait a minute. Cosecant inverse of cotangent of 180. I worked this out the other day and I ended up with 0. What did I do wrong? Okay, cotangent of pi was x over y, so that's undefined. So now I want cosecant inverse of this. So for these three, the only place cosecant's going to be undefined is going to be here, because the radius divided by 0. So why am I not getting 0 on the calculator? Arc cosecant, cotangent of pi. Did I type it incorrectly? Cosecant inverse of cotangent. Yeah? That one I'm going to have to get back to you on. I'm going to have to see. I don't know why that's not coming up. I don't see what, unless anybody can tell me what my mistake was. Now, you had the calculator today, but you will not have the calculator on the test. Okay. Remind me to start with this one tomorrow. As soon as the bell rings, which is going to be in just a moment, I'm going to run down and ask Mr. Heinrich about this one because I don't see what I'm doing wrong. I should be getting 0. Okay, so I will bring this back up tomorrow. In fact, I'm going to leave it right there. Well, okay, it's true. Now, arc cosecant would give me an answer, but arc sine would not. I wonder if it's because of that ratio, the reciprocal. The fact that one works and the other one doesn't. I wonder if that's it. Let me check on that, and I'll get back to you tomorrow. Okay.